In this lecture, we will talk about state reduction and state assignment of sequential circuit. In the previous lecture, we have learned the design procedure of sequential circuit, which is accomplished by the following step. In step number 1, the word description of sequential circuit was stated by a state diagram. In next step, we obtain the state table from state diagram. Further, the number of state may be reduced from state diagram or the state table by using state reduction method. In this lecture, we will learn how to reduce the number of state from state table by using the state reduction method. Next, uh, assign the binary value to each state if it contain letter symbol. So in this lecture, we will focus, we have a given the letter symbol instead of binary number for the state. So we will assign binary number to these letter symbols. The next step was determine the number of flip-flops required and the type of flip-flop. From state table, we derived the excitation table, and next step we did the simplification of the excitation table by using some simplification method, and we used the K-map. And then we derived the circuit output and the input of flip-flops. And in final step, we draw the logic diagram. So this lecture I will divide into two videos. So first, uh, in first video, uh, I will try to explain the state reduction method and state assignment. Now let us start with the state diagram. So we have a given state diagram. So I have given a state diagram. So I have some state A, which is represented by letter symbol A. Then I have a state B. Then I have another state which is C. Then another state which is D, and a state is E. Another state is F, and we have a state G. So let's start from state A. If we have 0 input, so the next state will remain the present state. So this is the input and this is the output. So if we have a 0 input and 0 output, the next state will remain the present state. So if we have 1 input, If input is 1 and output is 0, the next state will be this letter symbol B. Now from B, if we have if we have 0 input and 0 output, so the next state would be C. Again, if we have 1 input and 0 output, so the next state would be D. Sorry, we have one input and 0 output, so the next state is D. Now if we have one input and 0 output, from C it will move to state D. So it is 1 input, 0 output, and from C it will move to state, the next state would be A if we have 0 input and 0 output, and from D the next state is F if we have 1 input and 1 output, and from D the next state is E if the input is 0 and output is 0, and from E the next state is A if input is 0 and output is 0. And from E the next state is F if the input is 1, corresponding output is 1. Now from state F, this sequential circuit will remain at state F if input is 1 and output is 1. And from F, the next state is G if input is 0 and output is 0. From state G, it will move to state F if input is 0, sorry, if input is 1 and output is 1. And from state G, it will move to state A if input is 0 and output is 0. This left one is input and right one is output. Okay, now I will draw the state table, as you guys are already familiar with the state table. So we have given in state table, I will use the present state. This is the present state. Then I will use next state. And the output. So the next state depends on the input. So input could be a 0, x could be a 0, and x could be a be a 1. So here x is equal to 0. The output also depend on the input. X is equal to 1. So the present state, I will start from A. The present state is A, and the next state would be, here we can see that next state is A when input is 0. So corresponding output when the input is 0 is 0. Now if the present state is A, the next state would be B if the input is 1. So this is the state table, and corresponding output is 0 when input is 1. Now the present state is B. When present state is B, the next state would be C or D. So when the next present state is B, next state would be C when input is 0. So for 0 input, the next state is C, and corresponding output is 0. When input is 1, the next state is D, and output is 0. You can see here on left side is the input and right side shows the output. So if the present state is C, the next state would be A or D. So when input is 0, the next state is A. When input is 1, the next state is D. And the corresponding output when input is 0 is 0. When input is 1, corresponding output is 0. Now the present state is D. Next state could be F or E. So the next state could be F. The next state is E when input is 0, and output is 0. The next state is F when input is 1, and corresponding output you can see here it is 1. Now consider the present state is after D. I will consider E is the present state. Now the next state is A and F. So next state is A when input is 0, and corresponding output is also 0. The next state is F when the when the input is 1 and output is 1 in this case. Now the present state is F. Now the F has two possibilities. The next state could be F or G. So the next state would be G when input is 0 and corresponding output is 0 in this case. So the next state would be F when the present state when the input is 1 and corresponding output is 1 in this case. Now the present state is G, and G has two possibilities. Next state could be A or F. So next state is A when input is 0 and the corresponding output is 0, and it is the next state is F when input is 1 and corresponding output is 1. Now in designing process, we must have the minimum number of logic gates and flip-flop to reduce the cost of the final circuit. So in order to make the circuit cost effective, so we have to reduce the number of flip-flops as well as the number of logic gates. So here in this state table, we will try to reduce the number of states, and we'll learn in this lecture how to reduce the same states. So keep in mind that two states are said to be equivalent if each member of the set of input they gave exactly the same output and send the circuit either the same state or an equivalent state. So when two states will be equivalent, if for the same set of input they have same output and same next state. Okay, so same set of input, they send the circuit to the same state or equivalent state and they have same output. So here in this state table you can see, if I start from first row, in first row state A and in second row state B, you can see for same input they are going to different state, and whereas the output is same here in this case. So if I compare B and C, so these are going to different state, so these are not equivalent. Okay, so here you can see that the state E is going to state A when input is 0, and it is going to state F when input is 1, and the output corresponding output are 0 and 1. Similarly, the state G is going to A, going to state A when input is 0, and it is going to state F when input is 1 and corresponding outputs are 0 and 1. So in this case you see this state, these two states are equivalent. So these states perform the same function, so we can eliminate one of the state. Let me uh, uh, let me explain it again. The two states are same. We say the two states are the same if the present state go to the same next state for same input. So here you can see the present state is E and it moves to state A when input is 0, and present state G move to next state A when input is 0, and present state E move to next state F when input is 1, and present state G move to next state F when input is 1, and their corresponding outputs are also same. Now these two states are equivalent state. So one of state I can eliminate. Now I will eliminate this state. Let me use some blue color. So I will. And what to do? Here is G, and G will be replaced with the state E. Okay, now I will replace this G with the E. Now the state table will be reduced. Now I am going to eliminate this row, and this G is equivalent to E. Now again we will compare the states. Here you can see the state D move to next state E when input is 0, and corresponding output is also 0, and it moves to next state F when input is 1 and corresponding output is 1. Now see, the state F move to state E when input is 0 and output is 0, and it moves to state F when input is 1 and output is 1. Now I can say that the state D and F, these two states are same, because on same the same inputs have the same next state and same output. Okay, this state and these two states are same, so I can eliminate one of the state. So how to do this? What I will do, this one I will erase. I'm going to erase this state, and what I will do, I will replace F with D. So here F, I'm going to eliminate the state F. Now F will replaced with the state D, and this one will be eliminated. Let me erase this state. Okay, now this F is replaced with the D. Now I think further we cannot reduce this state. This is D, this is D. Further you can see that no two states are the same. Here you can see the state C move to next state A and D, and their corresponding outputs are 0 and 0. And state A, E move to state A when input is 0, and it moved to state D when input is 1. But here the outputs are different. Further, this state table cannot be reduced. Now you can see that uh, the state table is reduced. Now we have the required flip-flop will reduce, and the sequential circuit would be cost effective. Now the reduced state diagram, I can redraw the reduced state diagram as from state table I can draw the reduced state diagram. So it has a state A, shell state is A, the next state would be A when input is 0 and the corresponding output is 0. And you can see here the state A move to state B when input is input is 1, so it will move to state B, input is 1 and output is 0. And state B move to state C and D. So state B can move to state C when input is 0 and output is 0. And state B move to state D when input is 1 and output is 0. Here input is 1 and output is 0. So the state D move to state E when input is 0. So this is the state E. It will move to state E when input is 0 and corresponding output is 0. And state D move to the same state D when input is 1 and output is 1. And state E move to state A and state D. So it will move to state A when input is 0 and output is 0. And state E move to state D. So in this case the input is 1 and output is 1. Okay, sorry, this state C, I lost this state C. State C move to state A when the input is 0 and output is 0. You can see here it moves to state A when input is 0, corresponding output is 0. And state C move to state D when input is 1 and output is 0. So this is the reduced state diagram. You can see it is reduced as compared to previous state diagram. Okay, now this is the reduced state diagram. The next I have to assign the states to these. I mean binary states are the binary digits. I have to assign the binary number to these letter symbol. So binary state assignment uh, you can, okay, eliminate this state diagram. So we have given states. So we have state A, B, C, D, and E. Okay, there are four states, sorry, five states. So you can assign, I mean, 3-bit are required to assign the binary number. So uh, it is up to you. You can assign, I mean, uh, mm, 5 different combination, and these have no consequence on the on the on the circuit. I mean, uh, the circuit will work, I mean, will move to next state depending upon the inputs uh, and the inputs of the flip-flops and some external input. So okay, suppose I will explain 2-3 different way how to assign the binary numbers. Okay, this is the first assignment. Okay, you may assign 0 0 1 to A, and 0 1 0 you can assign to B, and 0 1 1 you can assign to C. Similarly, you can assign to D 1 0 0, and to E you may assign 1 0 1. So another way you can assign, so from 3 bits you can assign, I mean, 8 states. So here we have 5 states, so you can assign any binary numbers. So this is assignment 2. So here you can assign to A 0 0, and the next state B is, you can assign 0 1 0, and state C you can assign 0 1 1. To state D you can assign 1 0 1, and to state E you may assign 1 1 1. So it's up to you guys. Okay, I'm using this assignment 1 in this state table. So I will replace A with the 0 0 1. So A is 0 0 1. This is 0 0 1. So B is equal to 0 1, 0 1 0, and here we have a D was equal to 1 1 1 0 0. Okay, so 1 0 0. let me replace all these D with 1 0 0 1 0 0, here 1 0 0 and 1 0 0. Okay, next replace C with the, here we have A was equal to 0 0 1, and here we have replaced the C is equal to 0 1 1. Now this E is equal to 1 0 1, and this A was equal to 0 0 1. Now I will replace the B. B will be replaced with 0 1 0, and C was equal to 0 1 1. Now 0 1 1, and D is equal to 1 0 0, and E is equal to 1 0 1. So this is the state table. So this is the reduced state table. By using this state table, we can design a sequential circuit. So in the next video, I will design a sequential circuit by using this state table. So I will use the RS flip-flop, because in the previous lecture we have just used JK and T flip-flop, yet we have used. So in this lecture, so I will use RS flip-flop to design a sequential circuit by using this state table. So that's it. So we'll discuss this in the next videos. Thank you.